Hello everyone, I'm Stas and welcome back to the second part of my introductory tutorials about Vertex shaders. And this time I'm gonna talk about instances and using instances in Vertex shaders. At the beginning we would talk about difference between the world coordinate system and the coordinate on instance. And then I'll show you some techniques how you can use this information and render some results that would be hard to make without using Vertex shaders. So let's start from new component, new container. I'll call it record, and I'll put this file on my Patreon. So let's create let's start from one geometry because it would be easier to talk and to remind you some of the technique we talked earlier. Okay, here's our tube. It goes to it goes to no, it would be our model. And let's build a simple render setup. Geometry, camera, light, render, and the font. As I said in the first part, I prefer to start from the font material and then convert it to a GLSL material. And let's make it square. Okay. So here's our geometry. I'll make it visible. And let's yeah, I think we don't need anything to change anything here, so I can use the convert button, make a shader, our vertex, our pixel, and our debugging information. And yes, something going on with our lights, so let's connect it. So our lights is always in the same direction as our camera, maybe here. And let's dive inside. This is the second part, and if you don't really understand what's going on and what I'm doing right now, probably you should start from the part 1 and then come back and see this one. So I'm gonna make a vec3 new position. It would be equal to the same position. It's very same as in part 1. We would use this here. Nothing is changes. Probably I don't need to change normals. If I need, I'll fix it the same way as I did before. And let's scale it based on Y component. Okay. And let's move it, move a pivot anchor point or pivot point to the beginning of tube. Okay, here what we have with one simple geometry. Now what will happen if we make instances? Because with instances I'll made not a grid, a box with divisions, and 2 would be okay. So we would have 3 by 3 by 3 instances, and we need to increase the size a bit. Let's call it instances, instances, and use it here in our instance page. I will use it as a translate, and p1, p1, p2. And okay, let's make this tube a bit smaller. Maybe 1, maybe 0.2. Okay, good. So if I just made an instance and use this line of code, it would means the same scaling for every instance. Okay, but what if I want to use the y coordinate differently? What if I want these lower instances to be smaller and these higher instances to be bigger? How to do this? And for doing this, let's back to our unmodified geometry. And to do this, we could use not a global world position, but they use a function provided by TouchDesigner for us. It's called the instance translate, and we need y coordinate. Here we have actually 3 instances. No? Yes, no? Let's move it to see. Yeah, it's just because we in the middle of our coordinate system, so it seems like just 9 tubes, but it's not 9, it's 27. It just happens to look this way. So let's move our center to upward a bit. And as you could probably see, our instances that would be in the lowest part is very small, and this one is very big, so it's covered up our smaller instances. So probably it would be easier to show with not the scaling, but for example with translation. Yeah, here it's much easier to see. So the amount of translating our instances depends on y position. And of course the same could be applied to a scaling or rotating or doing everything else. And what if we want to do both of these? So what if we want that our y coordinate will affect both the global instance size and the local part of the instance? Then we could turn on the both of our lines, and here we have it. A different way of doing the same can be do it in one string, multiply it by here. It's the same. Or yeah, let me type a comment. So this one is the how to call it? I don't know. Okay, I wouldn't leave any comments. I hope you understand it. And let me show you the same thing with, for example, rotation. Let's rotate td rotate on x axis and here we have global rotation, oh sorry, local rotation, and we could do the same here. So now our instances rotated or bended, because it's bending is just a rotation based on one of the axes, because the lower part of our geometry is rotate on one angle, and the higher part is rotate on another angle, and that's create this bending effect. So I hope that's clear enough to give you idea of how to differentiate between the global use of axis and the local use of axis. And we have a third option. Let's comment this and this, and we could use TD deform Y. Yeah, like this. It's again scaling. If we do it like this, it will be translating. So it's kind of same as turning on these two strings, but it's a bit different in the same way. Let me show you. Okay, let's say do the rotation with this. TD rotate. What's going on? What's going on? Oh, it's because, yeah, sure. If you do rotation, it should be a multiplication. So here our rotation used this TD deform, and here our previous method. Yeah, with rotation it looks the same, but sometimes the TD deform gives a different result than combining these two strings. And if you go inside the help and write GLSL material, it says TD deform. It says that TD deform. Well, basically it says that TD deform should do everything for you, and you don't need to do this translate thing. But this TD translate, actually you even cannot find this function in the wiki. I just know it somehow. I can't remember why, but I know it. And yeah, so supposedly you should always use TD deform, but I'll show it to you later. Oh, okay, let me show it right now. Don't pay attention to everything else that's going here. There is a lot of things that's going on, but just look at how these instances scaled. And that was used TD instance translate. And if I instead use TD deform, the result looks a bit different. So just test the both option, the translate option and deform option, and choose whatever you like the most. Okay, let's go back to our simple project. And it's here. Okay. But what if we want to have a chop or a top and use the parameters from a chop or a top to translate, scale, rotate, or do something else with our instances. Okay, let me show it to you. We need the same amount of samples as our instance. So op instances num points. Okay, this is our noise. What we're gonna do, I don't know, let's do rotation with it. Let's do rotation. Let's use the lower period of a noise and let's animate it. It's maybe too much, maybe not, I'm not sure. And I call it sampling. So here in our GLSL material, we go to arrays page, put our chop here. A very important step, the array type we set as a texture buffer. The type we could change from flow to, it depends on how many channels we have. Maximum we can have 4, but we would also need to declare it in our code, GLSL code as well. And let's call it sampling, just sampling. Meaningless name, but yeah, why not? And in the code you a sampler buffer as sample, and let's turn everything off so we have our instances again. And let's use it. We have we need to say that please rotate the instance number 1 into degrees, into radians that set in this sampling chop on sample number 1 and instance number 4 and sample number 4 and so on. And maybe we'll do it later. So we need to know somehow the number of instances. It's actually not a float, it's integer. Instance. And we have, and TouchDesigner provide for us the variable, not a variable, a function for it. td instance id. So every time when the touch hits some point and need to do some deformation for this point, it will understand that this point belongs to this specific instance and use this instance ID to do something we would ask it to do. And what we need to do? New position should be td rotate rotate x, and here we need the radians. Let's make it in separate lines so the code would be simpler to read. float angle is texel fetch is a function that could address to a sampler and return the result. Sample fetch of a sample and instance. Okay. Now it should work. But it didn't. Why? It didn't because, yeah, as I mentioned earlier, but I forgot it myself, that in the code you also need to say that you need only first value. So only first channel. No, undefined where in, yeah, I'm just misspelled it. Okay. It hangs because it looks like it hangs on the upper part, because here our anchor is here, and we could make it stay in the middle. We could make it stay in the middle, and we would probably like to rotate in 360 degrees. So if we could type 360, it rotates too much because it's actually not angles but radians. And how to make it angles? We could use the function radian. So, oops, radians. Now it's better. It's still too fast, but because it's our noise is fast. Okay. The same thing you could do with top, but let's me make, for example, not a rotation, but something else. I'll use the noise top. I'll set it to 32-bit floor, nearest pixel, and we could use the same number 1, and not monochrome, and let's use the same. I just don't like typing, so I prefer copy pasting everything. Okay, we have our noise, and how can we use it? We can use it in a lot of different ways, but let's make something super simple, like changing the colors of instance. And of course I know that you could change the colors of instance here on instance page, but for demonstration it's easier to show it with a color than to come up with something more difficult, but maybe we'll do more difficult as well. Let's not null, let's call it top sample, and another meaningless name. I should really give some meaningful names. Okay, the difference here that if you use top, you use not a sampler buffer, but sampler to D. And here with a texel fetch, let's create a vec3 color. Let's call it eColor because it's instance color. It would be not this way of texel fetch, but instead give texel fetch only one integer. We need to give him the two integers because it's the top, and the top also have a width and a height, so it's two-dimensional. So we need to sayivec2, which integer vector, and as a horizontal component we use our instance, and we have only one row, so it would be 0, and we need to give them so-called load parameter. It's usually 0, and we need RGB. Okay, and it's our vertex shader, and all coloring happens in the pixel shader. So we need to give this information to a pixel shader. But it's actually already the set. Here our output of our vertex shader sets some vector for color to our pixel shader. Let's make it actually vec for color, and then we don't need this RGB. And this used here. This output of vertex set as TD instance color CD. And TD instance color CD is the color that we set up here on our instance page. But since we didn't use it, we could instead use our color from here. And I hope it will work. Yeah, it works. Good. Okay, let's make it less annoying. Okay, much simpler. Much, not simpler, but yeah. My eyes don't hurt anymore with this rotation. All right, what else can we do? Let's talk about the translation. Before that, we use only translation based on sum of x's. But of course, it's not the only thing that's possible. In GLSL, we have a lot of different functions. I think the best way to learn different functions is to go into different example on Shader Toy or in a TouchDesigner community and look how it's done. But another way would be to go in some Wikipedia or some another informational resource and just read the all functions or almost all functions that you could use. And come up with some idea how to use it. And for example, we have a distance function, distance. And distance returns the float, which would be a distance in some fictional units between 2 points. And these 2 points could be in 3 dimension. So let's try to use it. How could we use it? We could create some variable. Let's call it distance. That would use this distance function. Distance function, and as our points, we could use our TD instance translate and as another point, let's say it's let's set up it manually. Of course, you could set up with some chops or tops or here on vectors page. Okay, I call it one more meaningless name, up2. Let's define here our up2, uniform vec3 up2, and here where is our where is it? Where is our, here's our distance, up2. So now we have, for every of our instance, we have the float called distance, which sets the distance from this distance, too many words, from this to the value 111. We don't use the fourth value here. But how could we use it? For example, we could simply scale our instance. Maybe it would be too much, maybe not. Let's see. Let's multiply it by our distance. And yeah, it's too much. Maybe 0. It's not super visible. So something like this, yeah. And now if you move this, our second point, where am I? Oh, okay, our point is somewhere over here, so let's move it, for example, by x to 10, by y to 5, 8, I don't know. And let's, for example, here is our biggest instance, and we move, and if we move it here we have scaling on x, which is really visible. Let's make a scale by y also visible. Okay, our y component is somewhere between somewhere in the middle, around 5. So if we set it to, let's say, 12, yeah, here we have a bigger distance from the 12 to this is a much bigger distance than from 12 to here. So that's why these cylinders are bigger. Maybe 10 is enough. And of course with Z position we could do the same, and let's, for example, use -3, -8, yeah. Well, I hope you got the idea of a distance function. And I will show how to use it a bit later, how to use it a more meaningful way than we did here. And for now, let's turn it off. Let's turn it off. Yeah, we still need the information about instance. Okay, now it works. So what else could we do? Let's talk about sign distance function. If you saw my tutorial about ray marching, probably, or if you play by ray marching by yourself, probably you know what is sign distance function is. If you don't know, of course you could watch the tutorial, or I can give you a super simple example about this. Here in our polygonal geometry, all geometry is created by polygons. And here, if we lower our details, you could really easily see this. So all of our geometry, it's created by polygons, which looks like this. The different way of creating geometry would be a mathematical description of a geometry. Let's talk about the sphere, for example. If we have for example, point somewhere here, let's say in the beginning of in the 0 coordinate. What is a sphere? What is inside the sphere and what is outside the sphere? So if our sphere, for example, is 2 units, the radius of our sphere is 2 units, we could say that everything that's 2 units distance, the very same distance we used here, 2 units distance from the point of 0, 0, 0 is inside our sphere, and everything that's outside, everything that's bigger than 2 points from 0, 0, 0 is outside. So how could we use this information? And yeah, and here you could read it. So we give this some position and our radius, for example 2, and it says the same. So if the position minus radius is 0, we on the bound of a sphere. If it's less than 0, we inside the sphere, and if it's more than 0, we outside of sphere, and the same for different geometry. So what can we do with this information? Let's switch from our tubes to boxes, because it's easier to show with boxes. Here are our boxes. We have, let's center it to 0. We have, let's center it. We have a size of 4 for 4. Let's make it 10 by 10 by 10 boxes. So if I set this to 0.4, we have a box. A box consisted of different boxes. All right. Now we could use these sign distance functions. For example with a sphere. Example with the sphere. We could use this as a separate function because it's easier than type inside the main function. And now we could say float scale equals CD sphere, and our position is again our instance position, and our radius, let's use a 2. And now if we multiply our position to our distance, we should have a sphere. Well, we have an inverted sphere, which looks cool. It's inverted because over there we have a negative scaling, and TouchDesigner render it's, I don't know why, but it renders it as a cubes, and here we have a positive, which also rendered as a cube. But we could use a step function. What is step function? Okay, step function. Here's our books of shaders. You probably heard about it. It's a good free book about shaders and GLSL with interactive examples. And it's easier to show step function on the image example other than a geometry example. Here's our step function. It returns 0 if the value is less than 0.5, and it returns a 1 if the value is more than. And here, if I move it, so here is our 0, here is our 1. And this is our threshold. And we could use the same idea here. We could say scale equals step function uh, 0. So our boundary of our sphere is on the 0, so that's why our threshold would be 0. And we evaluate scale parameter. And now we should have inverted sphere. Yeah, we have inverted sphere because the sign distance functions works as inside the sphere we have a negative value, and outside we have a distance to the sphere, which is positive. That's why inside this cube actually it's an empty space. But if we invert this, like as minus scale, it should give to us the voxelized sphere. And this is a simple way to make voxels. Maybe not super simple, but it's a fun to play way to make. And if we multiply our division, so here we have 10 by 10 by 10. Let's use, let's set scale as, let's copy. Let's make it somehow more smart. How to make it smarter? We need we need our scale is 4 divided by 8. So we could copy this parameter and set scale as 4 divide, let's first insert this parameter, paste this parameter, and 4 divided by this. Okay. So now if we increase the number of our I had a problem because if I increase it too much, then my noise parameter isn't enough because it can goes only to 32 something, 32,760 56 or something. I don't know. It's 2 in the power of 16. Okay. Let's try to use something more interesting, like for example this, well, maybe not round box. Okay, why not? Let's use a round box just to repeat this process once again to make sure that everything works fine. Okay, and for round box we need now we set the round box, and for round box we need our position, then the size of our box, which is for example vec3 2.5 1.2 0.5. Let's have such a box, and the float parameter is how much rounded our box is. Here is our box. It's not rounded because our value is too low. Let's make it bigger, and now we have a little bit rounded box. And if I increase here, for example, to 8 and here to 5, it would be Well, not much more values, but I hope you got the idea. And if we increase the number of our divisions, maybe we need to recreate the colors a bit differently, and we will get the rounded box. Let's use yeah, something like this. Okay, that's probably enough about different ways of scaling and using distances, and let me show you this example. Now you would understand it. And by the way, probably it's time to thank all of my Patreon supporters, and if you want to take this file and not to type everything by yourself but took my example, you could subscribe to me on Patreon and get this file with this code and everything. Or you could look inside what we have and just retype it by yourself. Okay, what we have here, just for the simplicity, I'm not writing everything in the main function. I'm using the separate scaling function which do everything about the distance calculation and the sampling. And I have this noise here which gives a position of, let's call it fireflies. Yeah, bumblebees. Yeah, fireflies. These fireflies, here is the geometry with point sprite, just to visualize it. And this geometry works with our box, and the cubes is the same thing, and actually the same parameter. And to calculate distance, to calculate how much we should scale our cubes when the fly goes in or goes out, I'm using first time sampling from my top, then I calculate the distance, and then for every, oh yeah, the difference here, we have in our example we have only one distance, and that's why it's where is it? Here we have only one distance, so we could scale everything to this distance. But here we have several spheres, so we need to calculate distance for every sphere, and here I did it in the loop from 0 to number of our spheres. And this min function, it's keep the minimum between two positions, and I set the maximum position. Here is my maximum position where everything it begins to scale. Oh, oops, it's a minimum position. Here is my maximum position where everything it begins, and here is my minimum position. So if the distance to a certain sphere here, it's less than 3, it would keep this lower distance, and then it's calculate the same distance for another sphere, and in the end, for every instance, it scales on the minimum distance for every spheres. And I'm using not a step but a smooth step, which is okay, let me show it here. Here we have our step, but if we type a smooth step instead, it needs two values, maximum and minimum. If it's less than minimum, it gives 0, which in this case is black, and if it's more than maximum, it's 1, which is white, and in between it's just smooth interpolation, a ramp. And here I and there I did the same for my cube, because I want my cube to become smaller and smaller and not just either on or off. Okay, and that's it for this example. What else do I have to show you? Okay, here is my SDF function, and PBR materials. PBR materials, it's basically absolutely the same. You just choose the PBR material, set up everything you need with PBR materials, and then depress the button output shader, and you'll get another material which is GLSL material, and everything rest is absolutely the same. The only thing you should remember about is this. Usually in PBR we use substance. We use substance top, and this substance top did everything you need. But it didn't. This substance top wouldn't work in GLSL. So what you need to do, you need to choose substance select, reference your substance top, and select what you need: a base color, ambient, and so on. Here I did it for all 6 of substances. And now you reference it, for example, here you reference it as a base color, as a normals, as a height, well, you understand. And only after you reference everything, you press the output shaders, and here in output, all of that is inside as samplers. So it's only thing you should remember about, and everything else is the same. Here I'm used the SDF function for torus or link. Yeah, I use this one. Okay, and the last example is the custom attributes. Here I'm using the custom attributes for particles. It not necessarily should be about particles. It should be about anything you want. Could be about anything you want. Let me show you. Let's turn off our distance function, and so we back to our cube, and let's use for example particles as well. Okay, let me build it, a sphere that goes to particles. Okay, and yeah, I don't like this very sorted particles, so I usually insert a sort in between and choose random. So here I have my particles, and let me use this particle as instance template. So here's our particle system, and let me also play a bit with life expectancy and the turbulence and mass flow at 10 seconds. So we have a it's sorry, not a period, of course, it's seed. So we have every second our seed parameter is different, so the turbulence looks different every time. Okay, and the particle, if you choose the SOP to dot, you could see that the particle has different parameters. It has a p state, life, and actually 2 lives. This life 1 is the whole life. For example, if I set all particles to be the same life, it should be a 5, yeah. So all new particles is a 5 seconds by life maximum, and here is a current what's passed away. So how old this particle is. Okay, and you could use these parameters as the custom attributes, or you could actually custom attributes sets here in instance page, and you could connect any top or chop or SOP here. But to make something that's easy to understand, let me do it with particles. So let's grab a SOP to chop, and we don't need our position, we need our life. No? Why it's not sorry, you need to turn off custom, and here you type life. Okay, and here we have our life parameters, and probably it would be better to use not a particle but our null, in case if we change something in between these 2 parameters. So now we have 2 lives, and we need to, and for example, we want to scale our particles to be lower and lower when it's go through the life. Yeah. So we need to, for doing this, we need to divide the whole life of a particle to this current fraction. We could do it in chops, but we can do it in GLSL as well. Let me do it in chop because it's simpler for me. Even if I understand how GLSL works, I still prefer to do as much as I can inside the TouchDesigner. And we need here divide, not chops but channels. Divide channels. Yeah, it seems to be right. Let's connect the null and let's call it scale part. And here I'm using the last update, 2020 update of TouchDesigner, and they changed a bit interface of GLSL. And now you should, if you need a new parameter, you just press the plus button and you have a new tabs for it. And let's call it as part, for example, as part. and not forget to use a texture buffer. I think I did it wrong. Well, it's easier to show it this way, because now I could just use this sampler parameter and do the same as we did before with as we did with our rotations. But I wanted to show you before that, I wanted to show you the customs parameters. So let's use it here. Scale apart, live 0. So now we have every of our instance have custom attribute that calls scale part. And now if you go into a wiki, instance attributes, you could use these provided functions to get access to these attributes. Let's try. New position. Let's scale it. Custom attributes. I'm using custom attribute 0 because here I set on custom attribute 0. If you have several custom attributes, it would be custom attributes 1, custom attribute 2, and so on. And now we have our scaling, but it did wrong because it divides this channel to this channel, not opposite. But I can fix it just here. Oh yeah, it would be too much. Yeah, it would be too much. How can I do it? I could do it 0 minus. Yeah, now it works fine. So now our instances is the scales every time, and every time it descales because it uses these custom attributes. But again, you could do the absolutely the same if you just put the scaling into scaling parameter here. So it's up to you when to use the instances page and when to use GLSL code. The main idea is that if you want to do something less obvious, for example, this scaling with step functions, then you couldn't easily do it on instance page, and you need to do it in GLSL. And for example here, let me close this. For example here, what's going on, I'm using not left parameter, but I'm using the p-state parameter, because as I showed you earlier, every particle has this p-state parameter, which usually it's 1 when it's just a normal particle, but if it's hit something and you set this hit behavior, it's this particle that hits something, it's just spike at 9, I suppose. Yeah, at 9. So in the math parameter, I rescale it from 0 as a default value to 9 to 0, 1. And in GLSL code, what I did is well, I changed the color of particles, but it doesn't matter. Collision. Here's our collision. I'm fetching this chop, and if it's more than 0, so if it's not a default by default p state value, but when the particle hits, I'm changing color to red and the scaling a bit. It's not super visible, but if I choose a different scale, it's would be much easier to see. And if I choose the color as well. So here's some way of using it. But I'm sure you can come up with tons of different other ideas how to use custom parameters. And it's important to understand that it's not necessary should be done with particles. You could use the same custom attributes to any other geometry. For example, if you're using the groups in your geometry, you could set this group number as the custom attributes, or do whatever you come up with. So yeah, probably that's it for the introduction of Vertex shaders. I hope you like it. I hope you find it useful. If you create something interesting with it, please tag me on Instagram because I wanna see what you could create with these techniques. And if you want to have this file, please support me on Patreon. It helps me to create more tutorials. Yeah, and I think that's enough for introduction to the Vertex shaders, but of course you could do much more in it. So probably in half a year, or maybe a bit less or a bit more, I will create more advanced tutorials about Vertex shaders. And please leave in the comments below what you wanna learn next. So that's it. Bye bye. Enjoy. Have fun. Make art. Life well.